Firstly, let's see the course outline and that we are going to cover. This course is basically designed to teach the students about the analysis of electrical power system, which mainly include the comprehensive discussion of the introduction part, which includes the basic overview of power system, and the main topics are per unit system of calculations, one line diagram, impedance and reactance diagram, bus impedance, semi-admittance matrices, and their modifications and importance, which mainly describes the introduction of the calculations that you are going to follow throughout the course. So if you do not follow this introduction part carefully, then you might face a lot of difficulty in going through the rest of the course, which will take the major calculation part of the course. So this is the baseline which is included in the introduction part. So all the topics that we are going to cover in the introduction will be used in the load flow calculations or fault analysis, which are included in the remaining topics. The second very important topic is the load flow solution, which includes basically the scope of this solution in the power system, and then load flow problem formulation and the solution methodologies. Then there are different methods that we are going to follow for the load flow, which includes the Gauss-Seidel method, Newton-Raphson, and fast decoupled, and the load flow control. So these are the main topics that you will be studying in the load flow part. And if you take this terminology load flow basically it refers to something you might get that we are focusing on the flow of load in the electrical power system. So I think in the previous courses that you might have studied in this power domain, you have seen that there are a lot of focus on the load problems, that how we talk about the input output power and the power factor, or the different load problems that we discuss. That load is a very important part in the power system. So this is about how you transfer the load in the power system, or how load is balanced in the power system. This is all about the load flow that we are going to discuss in this course. Then the next main topic is the fault analysis in electrical power system, which includes importance of fault analysis. We will start from this importance of the analysis. Then we will see the types of faults, which basically includes the symmetrical and asymmetrical fault analysis. And symmetrical fault analysis, while solving that, we will be using Thevenin theorem and Z-bus phenomena, and we will see short circuit MVA in the topics. And in unsymmetrical fault analysis, we will discuss the symmetrical components, sequence impedances, and different types of faults, which includes line to ground fault, line to line fault, and line to line ground fault analysis of unloaded generator and power system. So I think fault analysis topic should be very clear. Why we discuss fault analysis is a very important thing, that when we have to analyze a power system, fault analysis is the major concern. There are a lot of type of faults that might occur in a power system. So how we analyze them, how we tackle them, these are the things that are of main concern for the power system. So we will discuss this area in the course as well. And in the end, our major topic of concern or discussion will be power system stability. So starting from the stability problem, its scope and significance, and then we will analyze the transient and steady state stability, power flow relationship for different machines, and then we will deriving a swing equation and solution, and there are different factors that affect the stability of the system. So stability, you might be familiar with this terminology, that it refers to how a system is balanced, how much stable is a system. So these are the overall course contents that we are going to discuss in this course, and these topics itself describe the course aims and the importance of this course. They are very important topics that we are going to cover throughout the course.